Alrighty, here we go. Law of sines. Now, why is this so important? It is amazingly important because everything that we've done up to this point only apply, and by everything I mean all the trig stuff we've done up to this point only applies to right triangles. This and what we do on Monday will allow us to work with non-right triangles. So it's very exciting. I can't wait. So here we go. Here's a pretty green triangle. 33 degrees, 47 degrees, 14, and x. And as it says in the problem, what happens if we want to solve a triangle, but it's not a right triangle? How do we do this? Well, the hard way to do it would be to turn this into a pair of right triangles. Okay? In other words, I could do something like this. And then set up a whole bunch of equations, an equation with the left-hand rectangle, an equation with the right-hand rectangle, but that's going to be a major problem. Okay. What we can do is implement something called the law of sines. Okay. By the way, before we get started here, how big is that angle? Beautiful. For those of you that were too lazy to do that calculation on your calculator, you're going to need your calculator, so go find it. Okay, we'll come back to that in a second. So how does the law of sines work? Well, I could take you through the whole process of where it comes from, but it's not going to mean anything to you and it's very complicated. So I'm just going to give you the law of sines. Okay. This is what the law of sines says. Now, this doesn't make any sense. There's two equal signs. How can you have two equal signs? Well, what you're going to do is you're going to get rid of the one you don't want. So let's say, for instance, I know about A and B. I'm just going to get rid of that sine of C over C thing. Or I have information about A and C. I'm just going to get rid of that. So we're going to set up a proportion. And by now, you should all be experts at solving proportions, so that's not going to be the problem. Okay, notice some little things. This is a capital A, meaning it's an angle. This is a lowercase a, meaning it's a side length. Same is true with the C and the B. Make sure you understand the difference between angles and sides. What commonly happens is that people start taking the sign of side lengths, and that makes no sense whatsoever. So don't do that. Okay. In red, I'll read it to you because it's important. In order to use law of sines, you have to have at least one of these ratios. In other words, you need to know at least one angle and the side opposite it. If you don't have that relationship, you can't solve it. If I just give you, for instance, 3 angles, not solvable. If I give you 3 sides with no angles, not solvable. Okay? Questions so far? Beautiful. All this is then, for the rest of the slideshow, is just examples of how to apply the law of sines. Okay. 2 different scenarios. Number 1 is solving for an angle first. Second scenario, solving for a side first. So let's go back to this guy we had in the first slide. Okay. The first thing I would say to myself is, self, do I know an angle and the side opposite it? And the answer is yes. If I didn't, could I find it? So for instance, we did this already, but I know that that's going to be 100 degrees. Okay. Now, before we start doing any calculations, which side is going to be the longest when we're done?
Line CB.
Correct. Emily, why? Is it because it appears to be the biggest in the picture, or is there another reason?
Well, it has the biggest angle opposite it.
Perfect. Good. Emily, let's stay with you. Staying with that frame of mind, which one will be longer then, AC or AB?
AC.
Good. So what we know without even doing a single calculation is that x should be smaller than 14. And CB should be bigger than 14 and whatever value we get for x. Okay, but we're going to start simple. We're just going to solve for x. Okay? And again, I started by checking to see if I have an angle in the side opposite it. So I know B in the side opposite. I'm looking for x, which is opposite C. And technically speaking, what I should have done, I was a little sloppy. That should be C, but I screwed up. Bear with me. Okay? So I set up my ratio. What's my ratio look like? It looks like that. The sine of an angle over the side opposite it, the sine of 47 over the side opposite, is equal to the sine of another angle over the side opposite it. Leia, how do I solve this?
You would like cross multiply.
Lovely. Cross multiply. And then divide. So I put 2 steps in there. I guess for some of you that I may have lost you, I would get x times the sine of 47 is equal to 14 times the sine of 33. And then divide by the sine of 47 to get down to that. Remember what we talked about the other day. You got to be careful with parentheses. Go ahead, plug that in your calculator, see what you get for an answer. Make sure you're doing it right. I will do the same. Lorenzo, what do you got, buddy?
10.4.
I got the same thing. Well done. Does that fit with what Emily helped us with earlier? Yes. It has to be less than 14. 10.4 is less than 14, so I'm convinced that you and I did it correctly, and I also put it in the slideshow that way, so you appear to have gotten the correct answer. Okay. Any questions on that? Now notice I could easily go on and solve for CB also. I could set up another ratio. When you set up that other ratio, by the way, use the 47 and the 14 because that's given information, and do the calculation all over again. Pythagorean theorem does not apply here. There's no right triangle. Remember, that goes away. Okay. No cosines, no tangents, none of that fun stuff. It's just sine, straight sine from start to finish. Okay? Questions before I move on? Okay. Sine applies here. How do I know that the law of sines applies here? How do I know that? Because I have an angle and the side opposite it. We're going to look for the measures of A and B. So now this is the different problem. In the previous problem, in this guy, we solve for a side length. In this guy, I'm going to solve for some angles. And hopefully you see that if I solve for, let's say, angle A first, which is exactly what I'm going to do, I could easily find angle B because all three add up to 180. Okay. Also notice, I need to solve for angle A. Why do I need to solve for angle A? Because I don't know how long this side B is. Whoa, I clicked already. I don't know how long that side is. Okay? So, we're going to solve for angle A first. Bobby, you there?
Yeah.
Could you help me set up my proportion, please? What am I going to do here?
Like the previous one?
Yes, sir.
I think it would be sine A
Over
over 9.
equals.
So sine 25
Uh-huh.
over 5.
Oh, beautiful. Okay. Bobby, last question, then I'll leave you alone. Is A going to be bigger or smaller than 25?
I think bigger.
Oh, I think you're right. Do you know why? Other than the picture looks that way? Don't trust the picture.
No, to me it's just a picture.
Oh, yeah, don't trust that picture. I'm a sneaky bugger. I might change it on you. Anybody else? Why is A going to be bigger than C?
Because the denominator 9 is bigger than 5. So for the sin of A, for it to be equal to each other, the sin of A has to be bigger than 25.
Sine. Right? Yeah, don't call it sin. Okay, solving this. Cross multiply. 5 times the sine of A is equal to 9 times the sine of 25. So the sine of A is equal to 9 times the sine of 25 divided by 5. Okay, everybody with me so far? Not done yet. Because how do I get A by itself? And you'll notice I left a gap here. I'm not as dumb as I look. I have to do an inverse sine. So this is the one where you do the inverse sine. Plug that bad boy into your calculator. Do that, please, to make sure that you know and I know that you can solve that. Be careful with parentheses. Emma, what do you got?
I got 49.5.
I got the same thing. And those are degrees. Good. Okay, so then I cheat. I cheat by saying, okay, angle B, which is the one I'm missing, is going to be equal to 180 minus 25 minus 49.5. Whatever that is. 180 minus 25 minus 49.5. 105.5. And now that I have all three angles, if I was feeling saucy, I could go and find the length of AC. The problem doesn't ask you to do that, but I could, because now I know the angle for B, and therefore I can use the ratio of the angle, the sine of the angle over the side. Okay? This doesn't seem too bad, does it?